Oh, there we go. So that is now recording. Okay, we're going to start off this week with just a little poll. I know that quite a few were really liking the polls, especially what came back from the survey that we were doing. So I'm going to start with a poll. And there's a few questions here. Just like we were doing a do now in class, I want you to have a go at answering these. There are just 3 questions. So I'm going to give you 2 minutes to answer these questions. But once you've answered these 3, I want you to put in the chat box what you think from last lesson or the lesson before that you thought were the most important things that you learned, or the things that you remember the most. Just pop one little thing in the chat box. Okay, I'm going to launch the poll and then I'm going to start the timer. So we've got just about 2 minutes to have a go at this. So all 3 questions, make sure you read all of the options first. Make sure you make your right decision. So have a look at all of the answers and then make your decision. There's an extra challenging one at the bottom there, question 3. So make sure you have a good think about that one. Think about it. So we've got sodium nitrate as a salt. What's going to go into sodium nitrate? Got an acid and an alkali to make a salt. So what's the acid and the alkali going to be there? Still got loads of votes coming in. Fantastic, guys. I've got 75 of you have now given an answer. That's fantastic. Well, we're nearly hit 100. Half of you have voted now. Well done. Okay, so we've got about a minute left. So that will make it perfect timing for all of you to vote. Question 1, we've got 91% of you so far. I've got that correct. That's really good. We'll go through all of these in a sec. Okay, yeah, the challenging one has definitely been quite challenging for a few. We'll go over that in a second. So just under a minute left. I've got 170 of you have now voted. So just about 45 left, 50 left. If you've only just joined us, we're just doing a poll based on our learning from the last 2 lessons. So it's going to be a revision session today. So have a go at these 3 questions. Once you've answered these 3 questions, just type in the chat box, Miss Tomlinson, what you think the most important thing that you learned in the last 2 sessions, or the thing that you've remembered the most. Pop that in the chat box. Are we getting some answers there, Miss?
We are. I hate to do this, but we've got one student who just keeps filling the chat up with ease, and that's Ryan Plays Roblox. So we don't know who that is, but we will have to get you blocked or removed. You need to stop doing that because it's actually ruining it for other students. Sorry, Miss, I didn't want to have to do that.
That's okay.
But,
that's
the
right.
students, yeah, just keeps blocking it up. We do have some wonderful answers actually.
Okay.
And let's have a quick look. So
Ramon, keep the poll open while we do this because we've got a few more little stragglers. So while Mrs. doing this, you can still have a go at the poll.
That's brilliant. So Ramon says that one of the important things is that they've remembered that water has a pH of 7, and that's neutral as well. Yep. We've got Lucy says the part that she remembers the most is the substances are acid and alkaline and what the pHs are for those substances. So that's really good as well. And then we've got a couple of highs. Acids have a pH lower than 7 and alkalis have a pH above. That's brilliant. We've got lots of people remembering what neutral is. So thank you very much for that. Florence, Niall, Alfie, these are all great. Walter, Tanae, and again, Ramon again. And yeah, these are great. And Lucy, brilliant. Thanks, Miss.
Great, guys. Really, really good. So I'm going to end the poll now. We had 201 of you respond to that. That's fantastic. So let me just end. And then I think if I click share now, you should be able to see this on your screen. Can we all see that, I think? So we can see that we had question 1. A neutral substance has a pH of 7. 92% of you got that right. That is fantastic. So pH 7 is neutral. Then we've got here what a neutralisation reaction produces, and 65% of you said a salt and water. So that's fantastic. Really, really well done. So a neutralisation reaction produces salt and water. And then this was our extra challenge one. So this was talking about our making a salt. So if you found this one particularly challenging, don't worry, because we are going to be going over that again today. But we had sodium nitrate is a salt. So it's made from an alkali and an acid. Now, what I wanted you to do here was to recognize which alkali and which acid made sodium nitrate. So here, 35% of you did get this one right. So sodium hydroxide is our alkali, and then nitric acid is our acid. So you've got that nitric tells us that it's going to be nitrate. But like I said, we're going to be going over that again in this session. So I'm going to stop that poll. Really well done for getting involved there, guys. Some fantastic ideas in the comments. So let's go. So I think we remember quite a lot from last time. Well done. Okay. Oops. So I've just got a little video, which is just a couple of minutes long. It's just a little song. I know that loads of you love our songs in science. So I'm just going to play this one. It's just going to quickly recap all of the sciencey stuff that we've done for acids and alkalis in the last 2 weeks. So just watch this. It goes over it in a really nice, fun way.
Yeah. Okay. It's a pH scale for solution whose an acid or base. Tell the levels of hydrogen ions present. Acid type hydrogen ions H plus concentration like a lemon. It tastes pretty sour, probably like a level 2 on the pH. Give it a test and it shows red on the limit. 0 to 7 acidic hydrogen ion for liquid and moving over to the blue litmus. It's a base bitter taste, slippery fluid. Hydroxide ions always find a success like a product for your drain. Need an unclog and on it. Another name for a base. Alkalis pH range from 8 to 14 high ions and a base type of hydroxide like toothpaste, soap, cleaning products like iron. And when a base and acid mix and neutralize H plus and OH minus combined, turn it into plain water. H2O plus on the side is a salt, for example, sodium chloride. So bases, mix them up with acids and what it makes is salt and water. Don't forget what the pH is. Measure up hydrogen ion concentration in an aqueous. Neutralize reaction of some other from acid and base. Neutralize reaction. Neutralize reaction. Neutralize reaction. Some other from acid and base. Neutralize reaction. Neutralize reaction. Okay, so that was just a little nice fun summary of all the bits we're going to go over today. So we're going to look at what an acid and an alkali is, and what our pH scale is and the different colors, and then what happens when we have a neutralization reaction. So let's get going. Oops. So we talked about acids, and we said what are acids, and they are a solution that is dissolved in water and gives off these H plus ions, so hydrogen ions. And by having these H plus ions, it gives us a pH that is less than 7. Now we looked at some different indicators, and we're going to have a look at those again in a sec. But our pH of less than 7. So we said that 7 was neutral, and then 0, 1, 2, 3, 4, 5, 6 would be acidic. We've got some examples that we could have at home. So we can have some less strong acids at home, so some weaker acids like vinegar, lemon juice, vitamin C is ascorbic acid. We've got lots of different acids we can have at home. Then talking about what alkalis are. So alkalis are slightly, or they are different. Rather than giving off the hydrogen ions, they give off hydroxide ions, so OH minus. And these have a pH that is greater than 7, so 8, 9, 10, 11, 12, 13, 14. And the sort of things we would find at home that would be alkalis would be toothpaste, bleach, drain cleaner, baking powder, and the ones that we would find in the labs that we would use most commonly would be sodium hydroxide. So here's just some examples of some of the names of some acids and alkalis that we might have that might help you to recognize them. And you can see that on our acids, most of them have acid on the end. And then on our alkalis, they tend to have hydroxide on the end. So that could help you to recognize an acid or an alkali. And then these are some of the hazard symbols that we might see on our acids and alkalis that we use. And just to remind you, the top one there is corrosive, so it can really be quite damaging to your skin or to your eyes or to tables. And then the one below, the exclamation point, that is that it's an irritant. Okay, last week we talked about bases rather than alkalis, and we said that bases also have a pH above 7, just like alkalis, but we said that not all bases are alkalis.
Some bases are insoluble, which means that they don't dissolve in water. So they'd be a solid and they'll stay a solid even if you put it in water. A base that will dissolve in water, so it is soluble, is called an alkali. So they're the ones that we'll look at, the liquids. They are soluble bases, so they are alkalis. And a base is a substance that will neutralize an acid. So we've had a little look at neutralization, talking about it going back to 7 to be a neutral solution. So bases have a pH above 7, just like our alkalis, but an alkali is a base that will dissolve in water. So not all bases are alkalis, but all alkalis are bases. Okay, so we talked a little bit about the pH scale, and it was this numbered scale that goes from 0 all the way up to 14, and it tells us how acidic or how alkali something is. And when something is neutral, it's neither acidic nor alkali. It's neither. And whether the acid or the alkali is weak or strong, it'll appear on a different point on this pH scale. So they're going to have a number assigned to them. In the lab, we can use some different indicators which will turn a different color based on these different pHs. And there's some really pretty colors that we can get. And we looked at a couple of different ones in our lesson a couple of weeks ago. So we looked at a few different ones. Now, the most common one that we'll see is universal indicator, and this makes the really, really nice rainbow. And I think most of us have really got this down, that we know that in the middle, we've got neutral is green, and then we're going along towards red to get to acidic, and then up to purple to get towards alkali. I think so many of us know this so well that when I was marking some of the work, I noticed that we had the question when they were talking about litmus paper and saying, what color is it going to go in neutral? And some of you just put green, which is, if we use a universal indicator, fine. But just be careful when you know this thing so well that you do check what the question is asking you. Just something that I picked up on there. But universal indicator is what we're going to see most often, and it comes up with this lovely rainbow. And the more that you get towards the acidic end, it's going to be more strongly acidic, and the more you get towards the purple end, it's going to be more strongly alkali. Sorry, Miss, have we got any questions coming up?
Yeah, just a few, just about what ions are, and I'm just answering one about bases, but I think you've been over that now. So, Miss, if you wouldn't mind just giving a quick explanation of what an ion is, that'd be brilliant.
What an ion is? Okay, so let's go back. So we've got these ions. We said the acids give off hydrogen ions, so they're free hydrogens. I mean, we're going to look at this more in GCSE. It's quite a higher level thing, but kind of the simple explanation is that it's something that has a charge assigned to it. So we've got hydrogen ions have this sort of positive, and then the hydroxide ions have this sort of negative, and they're separate, and they're not joined to anything else. Mister, do you want to add anything to that?
Yeah, so I think one of the easiest ways to understand what an ion is if you think back to the atom. So in order for us to get ions, atoms have to lose or gain electrons, or an electron. And you know that when you have an atom, it has no charge because it has an equal number of positive protons and an equal number of negative electrons. So if we start losing or gaining the electrons, they become charged, and that's what an ion is. So an ion is a charged particle. It's where an atom has lost or gained electrons.
Thanks, Miss. Sorry, I didn't want to go too complicated.
That's okay. Thanks, Miss.
Okay. So back to our pH scale. So we said that we've got these different colours, and we saw this diagram, which has got some different things that we might find at home or in the lab, and what their pHs might be. So we can see up in our strong acids, we've got stomach acid, we've got battery acid, and then as we're getting weaker, we've got coffee is slightly acidic, tomato juice. To our neutrals, we've got milk, sort of pure water is more towards the neutral, and then going towards our alkalis, we've got toothpaste, ammonia, oven cleaner, and soapy water would be an alkali as well. Okay, so another indicator that we looked at was our cabbage water. Now we can see that these go different colours. They still give us a scale from 0 to 14, depending on acid or alkali, but they show us a different colour. So we can see that instead of purple on our alkali end, we have yellow. So we would just need to make sure that we know what indicator we're using so that we can know what we're going for, because we might get it to turn yellow. It's a really strong alkali, but we might think that it's a weak acid if we don't realize that we're using cabbage water. So we need to make sure that we know what indicator we're using. And then finally, we've got litmus paper. So we've got red litmus will turn blue in an alkali, and then blue litmus will turn red in an acid. Now, comparing this to our cabbage water and our universal indicator, this doesn't really give us a number. It doesn't give us how strongly or weakly acidic or alkali it is. It just tells us if it is acidic or if it is alkali. So it's not so accurate. It just gives us an idea of what we're handling. Okay, I've got another quick poll for you here. So I'm going to pop this up. There's six questions here. I'm going to give you 2 minutes again. I might give you a little bit longer when I look at how the numbers are coming in. But for the last 2 questions, so question 5 and 6, I've put this table on the screen. We need to have a little look at that table to help you to answer. So 6 questions, thinking about what we've done so far on pHs, looking at our acids and alkalis and universal indicator, and then using this table. So I'm going to launch the poll now. So have a little go at this. And then I'm going to start the timer. There we go. Okay, so about 2 minutes to answer these again. So let's see if we can get even more of you answering than we did last time. We had 201 answer last time. Can we get more? So we're talking about ions in the first question. Then we're talking about pHs. Question about universal indicator. Question 4 also about universal indicator. And then 5 and 6 is using the table on the screen. So 20 of you have already voted. Fantastic. Well done, guys. Make sure you have a go at this. Have a little look. If you can't answer all of them, just have a go at the ones that you think you can do. Got about a minute left. Okay, nearly half of you have voted. Well done. If you haven't voted yet, just have a go. Maybe if you just get the first 3 done. Let's see how we've done.
Miss, I'm really sorry. My computer keeps dropping out for some reason, and that means I lose the questions in the Q&A.
Oh,
I'm
okay.
really sorry. It's not that I'm ignoring the questions that are coming up. It just every now and then it just keeps dropping out for some reason. So I apologise, Year 7. So do ask your questions again if I don't get back to you. I do apologise.
Okay, last few seconds. I've got nearly 100. I've got 175. Just going to give you another 10 seconds. If you haven't voted yet, just have another look. Oh, numbers are really shooting up now. Come on, guys. Let's have a little go. Tell me what you think. So 75% of you have voted. Miss, are there any questions coming up that I can go over quickly?
Just very quickly, I've had a couple of students ask what litmus is.
What litmus is? Okay,
Yeah.
So litmus is another type of indicator. So we looked at our universal indicator and we looked at cabbage water. Now, normally in school, we would have a go at using some litmus. I should have brought some along, could have shown you. But what we use it as in the lab is it's another type of indicator. But rather than turning all different colours like our universal indicator, it will just either turn red or turn blue, depending on whether it's been put into acids and alkalis. You can find it as a liquid, but most commonly you'll find it as little strips of paper, and they look kind of like those little post-it notes that you use to mark pages. And you would just dip it into your solution and it would tell you, yep, you've got an acid, or yep, you've got an alkali. Rather than telling you how strong or weak it is, it just gives you an idea of what it is that you've got in front of you. So it's just a different type of indicator. Okay, I'm going to end the poll there. I've got lots of answers coming in. So we had 195 of you vote there. That's fantastic, guys. Really, really good engagement here. I'm really impressed. Okay, let's share these answers then. So you should be able to see this on your screen. We've got question 1 said, what ions are given off by an acid? And 65% of you said H+ ions. Fantastic. So yes, our acids do give off H+ ions. We said, what is the pH of a base? So I put this one in there as a little bit more of a tricky one because we've talked about acids and alkalis, but we can also talk about bases, and bases are also alkaline. So our alkali is a soluble base. And 54% of us said pH 8 to 14, so an alkaline pH. So fantastic there. Well done, guys. If you didn't quite get that, don't worry too much. That's why we're doing this revision session. Just make sure that that's the one thing that you really try to remember from this lesson. So question 3 was saying about a sugar solution didn't change colour of the green universal indicator. What does this tell us? And 71% of you said that it's neutral. Yep, so our sugar solution would be neutral. Question 4, universal indicator is added to an unknown substance and it turns yellow. What is the pH? So fantastic. 71% of you said that that would be pH 3. So it's going to be acidic. So our yellow pH of a universal indicator is acidic. Now we're having a look at the table on the screen. So I said, using the table, which solution is alkali? And this alkali solution is here with our pH 11, which 67% of you got right. So our higher pHs above 7 is alkali. So 11 would be our alkali. And then which solution would turn red in universal indicator? And then most of us have said B. Yep, fantastic. Next closest was D. So vinegar, yes, is also acidic. That would probably be more yellow. Whereas the hydrochloric acid, too, that would be red. Okay, well done, guys. Fantastic. We've just got one more poll for this session, but that's a bit later on. Okay. Oops. So just going back to this strong and weak acids, which Miss did touch on again last week. This is something that you don't even need to know until GCSE, and even then it's higher level. So if this is something that you're finding quite difficult to get your head around, don't worry. If you do get this though, this is fantastic and it's really going to really help with your understanding all of this. So don't worry if this is a bit much, but just have a little listen in and we'll go over it again. So we've got strong and weak acids. You'll hear about these and we've talked about this in terms of ions. So a strong acid is one which will lose its ions easily, and it will do this thing called fully dissociate. So it means that the ions will all separate from each other and they won't be attached anymore. So I should have put the picture down the other way, really. But here we've got our strong solution. So you can see here that all of our little circles are all detached from each other. So that means that we've got a strong solution, a strong acid or alkali here, with all of our ions have unattached themselves from the acid or alkali molecule. Then we have a weak one, will not easily lose, so we'll only have them partially dissociated. So you can see here that we've got some of them are still joined together. We've got the yellow and orange still together, and then we've just got a few where they've unattached. So our weak one will only partially dissociate. So a solution that is strongly acidic will have more free ions. So we can see down here, we've got all of these yellows. If there are ions, they're all free. They're not attached to anything else. But like I said, that's a really tricky bit. So if that bit's a bit hard, don't worry yourself. Then last of all, we've got dilute versus concentrated. So I talked about this in terms of if you think about your blackcurrant squash and you've got a dilute solution, we'll have just a few particles and lots of water. So we can see here, if each of these pink balls is an acid or an alkali, an acid or an alkali particle, we've just got a few there. So that's a dilute solution. And then we've got concentrated, has more acid or alkali particles and just a few water or fewer water particles. So we can see here, we've got concentrated, we've got lots and lots of acid or alkali in here. Miss, have we had any questions come up on that?
Not on that, but we've had a few about litmus, and I just wanted to say that again, so litmus paper either comes as red or blue, and you have universal indicator paper, which is yellow. So the universal indicator paper changes the same colours as universal indicator, but litmus paper, if it's the red litmus and it's in acid, it stays red. If it's in a neutral, it stays red, but if it's an alkali, it turns blue, and then your blue litmus does the opposite. So blue litmus in acid turns red, in a neutral it stays blue, and alkali it stays blue. Have a little look it up about litmus. It is, you know, it's either pink or blue, and it changes the colour either to red or blue depending on the litmus paper that it is. It's something you need to get a little practice with. And then universal indicator paper is the yellow one, which does the same kind of changes as you would expect to kind of see with universal indicator solution. Hope that helps those of you who are asking about indicator paper and litmus.
Yeah, thanks, Miss. Okay, so I just popped that back on the screen, so that is there again for you, and these slides will be shared with you. Let's try and whiz back through to where I was. Okay, then this is just the diagram that we shared last week, so this is just a little summary for you to have a look at. So Miss Tomlinson last week talked to you about neutralisation and salts. So this is where we're talking about when we mix together an acid and an alkali, or an acid and a base, and we have a neutral solution at the end. So we end up with no free ions. So that H plus and the OH minus from our acid and from our alkali have joined up together and made water. And then our ions from our acid and our base have joined together to make a new compound, which is a salt. So we're ended up with salt, which is made from our acid and our base ions. And then we have water made from our H plus and our OH minus ions. So we mix them together and it's no longer acid or alkali, it is neutral. So the neutral solution is made if you mix together just the right amount of acid and base. So you have to have just the right amount of ions there so that you're going to have all of the waters be made. You're not going to have any leftover H plus or any leftover OH minus, because if you had H plus left over, it would still be acidic. And if you had OH minus left over, it would be, of course, alkali. So a salt that's made will depend on the acid and the base that are used. So we can say in general, acid plus base makes salt plus water, but we can say specifically what salt is going to be made depending on what acid and what base are mixed together. So we call this neutralisation. So we can see in this little equation here that I've made with some little diagrams, we can see that we've got our hydrochloric acid here on the left. I don't know why I'm using my finger, I should use the pointer. So we've got some H plus ions and some chlorine. So that's our hydrochloric acid, HCl. And then we have sodium hydroxide here. So we've got our OH minus ions. That's telling us that it is an alkali. And then we've got some sodium ions here. We end up with our salt, which is sodium chloride. So they have joined together, and then the OH minus and the H have joined together to make water. Now, this is a bit more of a complicated explanation of it for those of you that want that extra bit of explanation. We just need to know that the acid and base make a salt and water, and we can name that salt depending on what acid and base is used. Okay, so we can write our equations using our standard bit at the top here. Acid plus alkali goes to salt plus water. And we can write a specific equation for our neutralisation reaction by knowing what acid and what alkali we have used. So if we start with sodium hydroxide, that's our alkali. And when we name our salt, the first part of the name of the salt comes from the first part of the alkali's name. So it's going to be sodium something, depending on our acid. So we've got our alkali is sodium hydroxide. We mix that together with hydrochloric acid. That's our acid. And the last part of our salt is going to come from the name of the acids. That's why I've highlighted sodium and hydrochloric here. And we're going to see how they come together. So it's sodium hydroxide plus hydrochloric acid. Now, the name of the salt here, I'm sure some of you might be able to work this out already, but we've got the name of our salt is going to be sodium from our alkali and chloride, which comes from hydrochloric. So we've got sodium chloride. And then what else do we have? Well, we have water. So we've got acid plus alkali goes to salt plus water. The first part of the name of our salt comes from the alkali, and then the second part of the name of our salt comes from our acid. Now, if you're given the alkali and the acid, you can work out the name of the salt. But if you're given the name of the salt, you can work out the name of the acid and alkali as well. You can work backwards there. So I've got a couple that I want us to try. We've got 4 here, and or 5 here, sorry, and I've left a couple of gaps. Now, what I want you to do is to write what you think is going to be in the gap in the chat box and see if we can work these out. So I've given you at the top what each of these acids, what the second name of the salt will be. So hydrochloric acid will make a chloride, sulfuric acid will make a sulfate, and nitric acid will make a nitrate. Now that's the second half of the name. So the first half comes from the first part of the alkali. So let's have a go at this first one. I've got sodium hydroxide plus hydrochloric acid goes to sodium what plus water. What's the second part of that name going to be? If you pop that in the chat box, see how many of us can get that.
It's all coming through, Miss.
Yeah, we do it looking good.
We've got lots of people saying sodium chloride.
Fantastic, fantastic. Yeah, so sodium hydroxide and a hydrochloric acid will make sodium chloride and water. Fantastic. So I'm going to give you another one now. I've taken a little bit more out this time, so you've got to try and work out a little bit more.
Miss, just well done to everyone who's coming through. I won't respond to them all. I'll dismiss them, but these are all the correct answers. Just check with your chloride is CH, the spelling as well. But well done, guys. Well done.
Okay, well done. So next one, I've taken away a little bit more here. So I want to know both parts of the name of the salt. But here we've got potassium hydroxide and sulfuric acid. So remember, what part of the name of the alkali is going to come over to the salt? And what is the name going to come from the acids? Have a little look at the top, try and work it out, pop it in the chat box, and let's see how we do. What are we going to think it's going to be here? So we've got potassium hydroxide plus sulfuric acid goes to blank plus water. What is the name of our salt here? How are we doing, Miss?
So I'm still dismissing the chlorides. We are getting lots and lots of potassium sulfate. There are a few students who've put potassium sulfide. So you need to think about what goes in must come out. And I think that'll probably be easier once we start balancing the equations and using symbols, because you can see how many. But there's a couple of ones that aren't quite right, but everyone's having a good go, and we don't mind you making the mistakes. That gives us something to talk about. So everybody have a good go. We're never cross if you make mistakes.
Exactly. Really, really have a go. Well done. So those of you that said potassium sulfate, wonderful. So like I said, up the top here, I've given you what the second half of the name of the salt's going to be. So have a little check before you have a go. The next one, again, I've taken away something different here. So here I've got magnesium hydroxide, and it's reacting with an acid to make magnesium nitrate. But which acid? Which acid are we going to be reacting with magnesium hydroxide in order to make magnesium nitrate? Have a little go at that. That's quite annoying. I can't actually look in the Q&A box myself while I'm showing my screen. So magnesium hydroxide, what are we going to react it with to make magnesium nitrate? How are we looking, Miss?
We are getting magnesium nitrate. Someone's put nitrous oxide. No, not nitrous oxide. We've got nitric acid, nitric acid, nitric acid. So yeah, this is looking good. I think the person who just thought you were still doing it the other way around. That one mistake.
Yeah, no, that's fine. That's fine. So I took out something slightly different here. So again, up the top, we've said that we're going to make a nitrate. So we've made magnesium nitrate, and the thing that makes magnesium nitrate is nitric acid. Okay, we've just got 2 more, so we're going to do just to quickly go through these, and then we'll be finishing up. So I've got sulfuric acid this time, and it's making calcium sulfate and water. What is the name of my alkali going to be? So have a little look at this pattern that we've had down here. Got sodium hydroxide has made sodium chloride, Potassium hydroxide has made potassium sulfate. Magnesium hydroxide has made magnesium nitrate. What is the name of the alkali that's going to make calcium sulfate? What do we think?
We've got lots coming through already, Miss.
Mm-hmm.
I'll give them just a couple. I'll give them a couple seconds more just to add to them.
Yep.
So mainly we've got calcium hydroxide coming through. In fact, I can't find anybody except one person, but I think that was for the previous one. So they all look like calcium hydroxide.
Amazing,
Yeah.
amazing.
Yeah.
Really, really well done, year 7. This is tricky stuff. So fantastic that you're getting to do this. Even better that you're getting to do it on the other end of a screen. I'm so impressed with you guys. Okay, we've got one last one. So again, I've taken away a little bit more here. I want to know what the name of both of these are. So this is really, really tricky. Have a little go. Don't worry if you don't get this one. This one's really tricky. But I've got silver chloride here. What do you think is going to be the name of the alkali? And what do you think is going to be the name of the acid? So have another little look up here. Have a little look at the pattern that we've got. What do you think? We're going to have alkali plus acid. Let's pop both of them in the chat box. See if we can get it. I can see the Q&A numbers flying up, miss. So sorry. Well done, guys. There's 44 comments in there now. This is fantastic. How are we looking, miss?
Yeah, I'm really, really impressed, actually. We've got lots of lovely young people are saying silver hydroxide and water. We've also got some saying silver nitrate and hydrochloric acid.
Okay.
So one of the things I would like to say, even though there's lots of mistakes, they are really getting that it's a hydroxide for the alkali, which is really important.
Some really great tries here as well.
We've got silver hydroxide and hydrochloric acid.
Amazing.
Yeah, we've got... It is tricky, guys.
It's really tricky. Really, really tricky. Okay. So let's see what we should have got then. So over 67 of you now have tried. This is fantastic. All we need is for you to have a go, see what you can do, and then we can take it from there. But we should have got silver hydroxide. So that's the name of our alkali. So we have our hydroxide, and the silver gives us the first half of the name of our salt. And then we have hydrochloric acid because we have a chloride. Really, really well done, guys. Fantastic work there. Okay, so we've got one last poll just to take us to the end of our session. 5 questions this time. Going to give you 2 minutes again. This is just finishing up where we were. So we've just got, we've got 6 questions this time. Have a little go. See what you can get. The last 2 are super challenging. So if you can have a go at the last 2, fantastic. If not, just do 1 to 4. No worries. Just have a go. See what you can do. So I'm going to launch the poll. And we're going to have another 2 minutes here. So we had 201 of you vote on the first one, 195 on the second one. Let's see if we can beat it this time. So I want to know what's produced in a neutralisation reaction. Reacted sodium hydroxide with an acid, and we've produced sodium sulfate and water. Which acid was used to make sodium sulfate? What do you think the pH of sodium sulfate is? And then have a little look at the table to answer question 4 and 5. 4 and 5 are a bit more challenging. And then question 6 is the super challenge. So see if you can get that. So nearly 50 of you have voted. Fantastic. Well done. Okay, about a minute left. Let's have a go. We've got 75 of you have voted. Amazing. Just have a go. Even if you can only do the first two, just have a go. Nearly 100 of you had voted, guys. That's fantastic. Just about another 30 seconds. Okay, nearly 60% of you have voted. Fantastic. 10 more seconds. If you haven't had a vote, just have a go now. Fantastic work here, guys. Well done. Okay, let's stop that timer. Okay, I'm going to give you about another 5 seconds just to get in your answers if you want to have a quick go. Okay, let's stop that poll there and go through. Let's see how we did. So we've got what's producing a neutralisation reaction? Salt and water. Amazing, guys. Well done. 76% of you got that correct. Well done. So a neutralisation reaction, we've got acid plus alkali goes to salt plus water. Fantastic. Sodium hydroxide is reacted with an acid and it produces sodium sulfate. Which acid was used? And 54% of you have said sulfuric acid. Really well done. So like I said a minute ago in our questions before, these are really tricky and trying to remember these is really difficult. But we've got sulfate here, which tells us that we've got sulfuric acid. I can see that quite a lot of us thought hydrochloric acid, which I'd imagine has come from this hydro, which has stripped you up a little bit there. But we want to look at the name of our salt. So really well done. 54% of you got that. It's amazing. What would be the pH of this salt? So we've said that it would be neutral. So pH 7. Yeah, well done. Looking at this table on the screen, which solution is acidic? 67% of you said ammonium chloride, which is pH 4. Yes, fantastic. That is acidic. Then we've got our challenge questions. So we're having a look at the table again. We've got two solutions mixed together form a neutral solution, and 50% of you, or 49% of you, said ammonium chloride and sodium sulfide. So we've got the acid and the alkali. Fantastic. They would form a neutral solution. Well done. Oops. And then last question here, we've got our super challenge one. What are going to be our reactants to make potassium chloride and water? 49% of you said potassium hydroxide as our alkali and hydrochloric acid as our acid. Really well done, guys. Really impressed there with the amount of effort that's gone in and the amount of engagement here. I'm really happy with what you've done today, Year 7. Some really tricky stuff we've gone over here as well. So just final slide here, we've got some little videos that you can have a look at and then a really cool simulation if you want to have a go afterwards just to enhance what we've done today. But if you go into your Google Classrooms now, you'll all have a quiz to do. There's also a nice revision poster task. Rather than lots of questions for you this week, we're going to make a revision poster on acids and alkalis, everything that we've done in the last two sessions and today. So have a go at making your revision poster. You can do it online if you want to as a Google slide, or you can do it by hand and send a picture to your teacher, whichever you prefer. Lots and lots for you to be getting on with. But just remember, you only need to work for 45 minutes today after you've watched the webinar. Miss, have we got any more questions that we can go over?
No,
quick, or we good to finish?
I think that's it. I think they're desperate to get away and have a break.
Yeah.
So,
okay. We've run over by a minute.
We will see you next week. Don't forget to contact your teachers if you're not sure about anything, or please email us. Thanks, Year 7.
Bye.
Bye.